Hello viewers, welcome back to this class. Today we'll be talking about logistic growth model. Logistic growth model. This is more realistic model that factors the carrying capacity of a population. The carrying capacity is the maximum number of individuals. Logistic model states that the time rate of change of population is directly proportional to the population of the resources limitation. In that case, we are going to have dp all over dt, the time rate of change of population, is directly proportional to the population of the resources limitation. We have p1 minus p all over m. Our 1 minus p all over m is our resources limitation. As the population grows, the availability of resources decrease. As population grows, the availability of this decrease. 1 minus p over m, the resources limitation state that the larger the population, the less growth. Assuming we have 1 minus p all over n as our p is approaches to 1, we are going to have 1 minus 1 all over n. Assuming we have our p is approaches to k, and we have our p is approaches to k also, we have 1 minus k all over n. All these factors is telling us that the terms of this represent the fraction of available resources. The terms of this represent the fraction of the available resources. When p is more smaller than m, that is, as p approaches to what? To m, we are going to have what? The slow down the growth rate is going to slow down the growth rate of this. And also, when p is equal to m, that is, our 1 minus p all over m is also known as what? 0 is equal to 1. We are going to have what? We are going to have measure. This measuring the growth, this measuring the population growth stop. That is, it let the population growth stop. This is a fraction of a what? Is a fraction of a resources limitation. So how can we now solve this? This is in form of differential equation. How can we now solve this? Remember, you have the rate of change of population is directly proportional to p into 1 minus p over m. Cut. So dp all over dt is directly proportional to the population of the resources allocation. In this case, we are going to have dp all over dt is equal to kp 1 minus p over m. So this is what? Is a differential equation. How can we solve this differential equation? We can solve this by using variable separable. That means we are going to separate the variables. We now have dp is equal to kp 1 minus p over m dt. So for me, I can divide both sides by, I can divide this one by what? 1 minus p over m, because this kp 1 minus p over m, I want to separate it. I have to take this one to here. So we now have dp is equal to p 1 minus p over m, then I will now have k dt. K dt, that is, this will be able to cancel this. What I did here is p 1 minus p over m dt. I divide both sides by what? P 1 minus p over m. So this is able to cancel this. So I will now have, I can write this one as this 1 minus p all over m dp, then I will have what? K dt. So it means I've separated this variable, that this p is taking this and our k is taking dt. So what are we going to do next is what? After we have separated the variable, we have to integrate both sides. So how can we integrate both sides? So before we integrate both sides, this is a what? It's a form of fraction. We can solve this one as a fraction. If you have 1 minus p over m, so Sm of this is m. M is 1 is there is 1. M divided by m is what? M times 0. We are going to have m minus m divided by m is what? 1 times p. I'm going to have m minus p over m. So 1 minus p over m, when I solve it, I get what? M minus p over m. So in this case, we have 1 over p m minus p all over what? M dp is equal to k dt. So in this case, our m, this is m minus p is over. I can take this one to here. You have 1 times m, I will not get m. So I will now have m all over p m minus p is equal to what? K dt. So in this case, I can now integrate from this, that is, since I have solved this, I can now integrate both sides. So integrate both sides. If I integrate both sides, what am I going to get? So m all over p m minus p dp is equal to what? K dt. So if you look at this is a form of, if you integrate this by using is a standard integral. So we have to make this one as a standard integral. You cannot integrate this. This one is having m, this one is having p. We can apply partial fraction to this so that we get a value for p as well as m minus p. So the reason why we're using partial fraction is that whenever we have a polynomials, that is, we have numerator having polynomials or denominator having polynomials, and also if you can separate a value together, maybe two values from each other, this is why we are using partial fraction to solve. So we can apply a partial fraction to solve this. In this case, this is m all over p m minus p is equal to a all over p. A will take p, another constant will take m minus p. So for me now, you can LCM of p m minus p, you are going to get a m minus p plus bp. So in this case, what we have here is m. So m is equal to, if I open this bracket, I'm going to obtain am minus ap plus bp. So for me, I can equate the coefficients. It means this one is having a, the coefficient of m is what? 1. So I can equate a is equal to 1. This is p, this is p. So the coefficient of p is a minus a, and the coefficient of b is what? Plus b. The coefficient of p is plus b. Since we don't have a value here, I can make it 0. So this one can be in form, I can solve this simultaneously. Since a is equal to 1, I can easily get my b. I will just substitute whenever I see a in an equation to b. So I'm going to have minus 1 plus b in equation 2 is equal to 0. So for me, I will have b is equal to 0 plus 1. I'm going to have what? I'm going to obtain 1. So our b will be 1. So in this case, I will now go back to here for my original value that I have obtained. What did I have here? I have a plus b. I will now have what? 1 all over a is 1, b plus 1 over what? m minus p. If you look this one, it means this we have simplified this by using partial fraction to solve it. So I will now apply it to here. So m over p m minus p is now be 1 all over p plus 1 all over m minus p. Got it? So I now 1 all over p plus 1 over m minus p respect to dt is equal to k dt. So I can easily what? I can easily find the what? Find the integral of both sides. If I integrate 1 over p, I'm going to get what? Lim p. 1 over s, I'm going to get lim s. If I integrate m minus p, if I differentiate this denominator, respect to p, I'm going to have what? 1. If I differentiate m, it will be 0. 0 minus 1, I'm going to have minus 1. So it will now be 1 all over minus 1 ln m minus p. I'm going to get minus ln m minus p is equal to, if I integrate a constant, the respect to that value, respect of that t, will multiply the constant. This one is a what? Respect to t, that is the t will multiply k. I'm going to have what? Kt. Then remember to add your constant integration sign. So our k is a constant. So what are we going to do here? In this case, I can write this like this. Ln, since this is ln p, this is ln, I can take minus its division. This one, according to what? Laws of indices. Since ln is common between them, I can take it as 1. Ln p all over m minus p is equal to kt plus c. For me, I can take exponential of both sides. Taking an exponential of both sides, I'm going to have exponential ln p all over m minus p is equal to exponential kt plus exponential c. So for me, this one will be able to cancel. P all over what? M minus p is equal to what? Exponential kt dot exponential c according to laws of indices. So for me, I'm going to have p all over m minus p is equal to c exponential kt. So I can let c is equal to a. So I can have p all over m minus p is equal to what? A exponential kt. So we are not done yet. I want to make p the subject of this. So our p must come out so that we can get our p must be equal to all this. How can we do this? So I have to rub this place because there's no way I have to do it here. I can take the reciprocal of both sides. Taking the reciprocal of both sides. Reciprocal means what? I will make my numerator to be denominator, and I will make my denominator to be my numerator. So I will now have m all over p is equal to a exponential kt over 1. You know, this is 1 over 1 already here. This is what? A exponential kt over 1. So it will be 1 all over a exponential kt. Remember, according to laws of indices, if you have 1 all over s, I can write it as s inverse. S is power minus 1. So since I have 1 all over a exponential kt, I can make it as a exponential minus kt according to laws of indices. So what are we going to do next? We can what? We can cross multiply. So this is p, so we can get the value for p. So I'm going to have m is equal to p a exponential minus kt. M minus p, m minus p, m minus p. So I'm going to have m minus p is equal to p a exponential minus kt. So for me, I can take my minus p to the other side. M is equal to p a exponential minus k plus p. I can write this as this. M is equal to p a exponential minus kt plus 1. If I use this to multiply, I will get this plus 1. So what can we do? We can divide both sides by a exponential minus kt. So what am I going to have? I'm going to have a exponential minus kt plus 1 all over a exponential minus kt plus 1. This will be able to cancel. If this one cancel, I'm going to have p is equal to m all over 1 plus a exponential minus kt. So this is our formula we derive from this. So this is our formula for logistic growth model. So in some textbook, you may find your k as kp mu. Our k is a constant. they can represent it as any mathematical symbol. It can be mu, it can be alpha, it can be beta, it can even be c. Since our k is a what? Constant, and we use k as a constant. So that's why I use k. Some textbook you may find k as mu. You can write alpha, even beta, even they can use star. So because k is a constant already, normal form of constant, that's why I use k. So this is our p of t, m plus 1 plus a exponential minus kt. So this is what? This is our general formula for logistic growth model. So our m is our carrying cap. Our m is our maximum. Our m is the maximum capacity, while our k is our growth rate. The maximum carrying capacity is our m. Our k is the growth rate. Then our t is the time. Then our p of t is the population. Now, if you are given find at t is equal to 0, at t is approaching infinity, what are you going to get? So if you have to find this one, so p of t is what? M all over 1 plus a exponential minus kt. At t is equal to 0. So let's solve at t is equal to 0, 1. It means whenever we see t, we are going to put 0. So we have p of t is equal to m all over 1 plus a exponential minus k. Our t is what? 0. So we have what? P of t is equal to m plus 1 plus anything raised to power 0, we are going to get a exponential minus k times 0 is 0. Minus 0 times 1 is 0. So we are going to have p of t m all over anything raised to power 0 is what? 1. 1 times a, 1 plus a. This is at t is equal to 0. I have what? P of t is equal to m all over 1 plus a. At t is equal to infinity. What are we going to get? We are going to get p of t according to this formula, m all over what? 1 plus a exponential minus k infinity. If infinity, anything raised to power infinity, it will be all 0. It means all this place, a exponential minus k, it will be 0. So we're now going to get p of t is equal to m all over 1 plus 0. We're going to get what? P of t is equal to m over 1, which is what? Which is m. So at t is equal to infinity. Population, the time of the population is what? M. The population of the time is what? Is m. At t is equal to what? 0. We have what? The population at the time occur. M over 1 plus a exponential 0. Let's get m over 1 plus a.